Hi, you guys. So today we're going to try something a little bit different. I haven't ever tried to do this before, so we're just going to give it a shot and see how it goes. But I figured since you guys are home on an e-learning day, we could still get some of our notes knocked out. Now, I realize that you guys may or may not have your geometry notes with you. If you do, then it would be great if you would follow along and fill them out. If not, then go ahead and watch this video, and then you can go back and fill them out later. That is if you do not have them at home today. So we are going to start on section 6.6 and we're just going to do 6.6. And we're going to talk about two more shapes today. And the first one, trapezoids, actually they gave you a definition on the first page under the vocab builder. And just in case you are not familiar, a trapezoid is a quadrilateral, so it always has four sides with exactly one pair of parallel lines. So in this case, the two bases will be parallel, and then we have a set of legs that are opposite of each other. Now, we have different kinds of trapezoids. We're going to talk about a special type in just a minute. So we have to be a little bit careful in what we assume about trapezoids. We have base angles, which all four of these angles that are in the trapezoid are all base angles. And again, we're going to talk about a special type in just a minute. So I don't want to get too far involved into this before mentioning the actual type that we're going to work with. So looking at the top of the next page, we are actually really most of the time only going to deal with isosceles trapezoids. And again, they're still quadrilaterals. They still look like a regular trapezoid. But just like isosceles triangles, isosceles trapezoids each have a pair of base angles that are congruent. And the opposite sides, the legs of the trapezoid, are going to be congruent, much like two sides in an isosceles triangle are congruent. So first of all, we know that each pair of the base angles are going to be the same. And then we also know that if it's an isosceles trapezoid, the diagonals are congruent, much like a rectangle. All right, so looking off to the right, it says if trapezoid, TRAP, is an isosceles trapezoid with bases RA and TP, so the two parallel sides, then angle T is going to be congruent to angle P, and angle R is congruent to angle A. So these two angles are the same, and these two angles are going to be the same. All right, in the trapezoid below that, it says if ABCD is an isosceles trapezoid, then I know that AC, so the diagonal going this way, is going to be congruent to BD, the other diagonal. And sorry, that's a really bad representation. Assume that goes into that corner for me, please. Thank you. All right, so it says if ABCD is an isosceles trapezoid and AB, so this side is 5, then because these two sides are the same, then CD will also be 5. The only time this is guaranteed to happen is if it is specifically an isosceles trapezoid. Okay, and moving on, we also have a mid-segment theorem for trapezoids, which is very much like the triangle mid-segment theorem that we talked about a couple chapters ago. And you guys did really well with the mid-segment, so hopefully some of this will make some sense. So first of all, the mid-segment of a trapezoid is parallel to both of the bases. So in this case, MN is our mid-segment, and the bases are RA and TP. Okay, so this is a base, this is a base, and then that line in the middle is our mid segment, and that is a lot like what it looked like in a triangle.